Hello everybody. In this video we're going to be talking about modules and particularly how Microsoft Small Basic implements modules. What is a module? Essentially a module is a block of code that we can wrap up and name. And we can provide a name for it so that we can call it from anywhere within our program. And the ability to call it from anywhere enables us to avoid duplicating code. So the code that's inside of that module, we don't have to type it in every time we need it. Instead, we just write it once, and then whenever we need it, we just call it. So it avoids having to duplicate code, and also it structures our program in a way that makes it easier to read, because if you have a program that calls 5 modules, each one does something for you, then you can make the main part of your program very simple in the fact that it would just have 5 lines of code, and it would abstract all the details out to those modules. Now, we use the term module, but keep in mind that that term is not generally used in the programming world. The typical term that we use is something called a procedure. So the module and the procedure we're going to consider equivalent. And when you look at a procedure, you can further divide that into 2 other pieces, one of which is called a subroutine and the other is called a function. The only difference is that a subroutine doesn't return anything back to the caller and a function does. Now, in Small Basic, we have some limitations on procedures. First of all, it only allows us to write and call subroutines. The second, perhaps more significant limitation is that you cannot pass in data into the subroutines, which basically means that all of the variables have what we call global scope. And what that means is that all of the subroutines see all of the variables. So anytime you start working with a variable, it's open for all of the subroutines to see. It's shared across the board. Most languages don't have those limitations. They, in fact, when I say most languages, we're saying C#, Java, C++, Visual Basic, and so forth. The way they work is that you can write a subroutine or a function. You can pass data into either one. And when you declare a variable inside a procedure, it has local scope. Now what that means is if I'm inside of say a subroutine and I create a variable inside of it, that variable will only exist in that subroutine. As soon as that subroutine closes, the variable is destroyed. But in Small Basic, it's simpler. Variables, once they're created, they exist for the life of the program and they're visible everywhere. So the limitations that are imposed in Small Basic actually make life easier for the programmer, which was their intention. But it's not realistic in terms of what most languages do. So there's pros and cons to their approach that they've taken. With that said, now I'm going to go into Small Basic and I'm going to illustrate to you why it's helpful to use subroutines. So I'm going to write a program, and it's going to estimate how much fertilizer you need, since it's springtime here when I'm recording this, how much fertilizer you need to fertilize a lawn. And the program will subtract the area of the house, driveway, patio, storage shed, and we'll just leave it at that for now. Obviously, you would want this to be a little bit more flexible if you could, but we don't have the arsenal to be able to do that yet. We have to get through a few more chapters. So we're just going to assume that the program is going to assume that there's a house, a driveway, a patio, and a storage shed. So what are the tasks in this program? Well, we need to get the length and width of the yard so we know what the starting area is. So calculate the starting area. Then we need to get the length and width of the driveway. Calculate the area of the driveway and subtract that area from the total area that we have to work with. Or I'll say from the total fertilizing area. How's that? Now I'm going to copy this block and paste it several more times because we've got our driveway. Then we need to deal with the house. You know what? I really should put the house first. Let's do that. We'll start with the house. Then we'll do the driveway. Then we'll do the patio. And then we'll do the storage shed. So we get the length and width of the entire yard, and we calculate the starting area. We get the length and width of the house, calculate the area, subtract it out, and then we do the same thing for the driveway, for the patio, and for the storage shed. And then at the very end, we're going to display the actual area to fertilize. So let's write this program out without using a subroutine, and then let's consider it and go from there after we built it. So first of all, I'm going to bring up a text window, and I'm going to ask the user enter the length of the yard. I'm going to create a variable called yard length, and I'm using the camel case notation here. Notice it's yard length, two different words. I put the first word in lowercase and then capitalize the second word in the string. So I'm going to read a number here. I'm going to copy that and I'm going to paste in the code and change it to width. And then I'm going to change this variable to yard width, like so. So we get the length and width of the yard. To calculate the starting area, we'll call that yard area. It's going to equal the yard length times yard width. Now, I'm going to take this block of code and I'm going to copy it and do the same thing for the house. So my variables will be called house length and house width. So this is what I've got so far. I get the length of the yard, the width of the yard, calculate the area. I get the length of the house, width of the house, and then I need to calculate the house length times house width here. And I need to do this for the driveway. It helps if you can spell here. Driveway length times driveway width. Now I missed a step right here when I did the house. It says subtract that area from the total fertilizing area. So back at the top when I got the yard length and the yard width, I'm going to create a variable up here called fertilize area and set it equal to yard width. So we're going to start with the assumption that the entire yard is the fertilized area. But after we've asked for the house information, we're going to say that the fertilized area equals itself minus the house area. And what that's going to do, it's going to take the fertilized area, subtract out the house area, and take the answer and set it back to the fertilized area. And what that effectively does is it reduces the area to fertilize by taking the house out of the picture. I can take that same line of code and put it in for the driveway. So now after I take care of the house, I get the length and width of the driveway, I calculate the area of the driveway, and then I go to my fertilized area and I take the driveway out of play. Then I need to do the patio. So I'll take my code, copy, I'll come down into the patio, and I'll alter my code here a minute. Calculate the area of the patio. Is length times width. Subtract that area from the total fertilized area. So fertilized area equals itself minus the patio area. Then we have finally the shed. So again, I'm going to copy this code up at top here. And then I have a shed length and a shed width. Shed area equal to shed length times shed width. And then I subtract the shed out, so the fertilized area equals itself minus the shed area. this point, I'm going to have reduced the fertilized area down by taking out the house, the driveway, the patio, and the shed. So at this point, I can write out to the user the area you need to fertilize is space, and I'm going to concatenate in the fertilized area. So the area you need to fertilize is space. I plug in the fertilized area and follow that up with another space and then square feet. I guess it wants me to keep it all in the same line, so I'm going to just, yeah, it fits. Okay, so the area you need to fertilize is space. Area number gets plugged in here, then a space, and then square feet. So that's my program. If I look at the entire program from start to finish, I can't quite fit it all in, but again, here's the top. I get the length and width of the yard, calculate the initial area to fertilize, and I screwed that up actually. You know what? This isn't right. This code should look like this. I calculate the starting area. Yard area equals yard length times yard width, and the fertilized area starts out being the entire yard. Then I get the length and width of the house, get the area for that, calculate the house area, and I subtract it from the fertilized area. Then I get the length and width of the driveway, calculate the driveway area, take that out of the total area to fertilize, get the length and width of the patio, calculate the patio area, subtract that out, get the length and width of the shed, calculate the area of the shed, take that out of the picture, and then at the end I print out the actual area they need to fertilize. So I'm going to save this program. Really, I should have saved this a while back, but fertilize area, and then I'm going to run this. Okay, gave me an error on line 77. Gave me an error on line 73. Encountered unexpected end of line, blah, 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 okay? That's because I forgot to put in the closing parenthesis. And of course, I did that on purpose just to illustrate to you guys that you really need to make sure you close those parentheses out. You believe me? Good. I've got you passed through on that one. Okay, so I'm going to run it again. And let's see here. Okay, the length of the yard, let's say we're at 90 by 240. We'll say our house is 60 by 20. Let's go 60 by 40. Driveway, 10 by 50, I don't know. Patio, we'll go 10 by 10. Shed, 8 by 5. And so then the area that we need to fertilize ends up being, in this case, 18,560 square feet. Now, if I wanted to, I could print out all the intermediate steps that get me to that point, but I'm going to assume the user doesn't care about any of that. They just want the final number, and there's the final number. So that's my program, okay? Now, let's analyze this for a second. Notice there's a lot of duplicate code in here. The questions I'm asking, the area calculations, it's all following the same pattern as I work through this thing. And whenever you see a duplicate block of code, or you see the same group of code doing the same thing over and over again, it's a good place to think about using a subroutine or multiple subroutines. So let's think about how we're going to do that. I'm going to save this video, close it out and publish it, and I'll do a part 2, which will be the conversion of this program into a subroutine. So I'll see you back in the second part.